Hi everybody. Today starts our first day of notes in our new section, which is 4.4, Polynomial Zeros. Our goals for today will be to use the synthetic process, to factor polynomials, that might be may not be factorable by hand. And the only definition we need to talk about before we start our notes is the factor theorem. The factor theorem states a polynomial f of x has a factor x minus k if and only if f of k equals 0. In other words, the remainder is 0. Examples. So let's see how we're going to put this factor theorem to work. Number 1, the directions for these are factor given 1 factor. Our first example will be x cubed minus x squared minus 2x plus 8 by x plus 2. So I am told right now that x plus 2 is a factor. Based on the factor theorem, if x plus 2 is a factor, I know that when I divide, I should get 0 as a remainder. So let's see what happens. And what tool can I use? Well, when I look at what I'm dividing by, x plus 2, this is a linear factor and the coefficient here is 1. So I know I can actually start this off using synthetic. So negative 2 will go on the outside of my synthetic box. Let me check for placeholders. 3, 2, 1, 0. No placeholders needed. So 1, negative 2, 8. Drop the 1. Multiply, I get negative 2. Add negative 3. Negative 2 times negative 3 is 6. Negative 2 plus 6 is 4. Negative 2 times 4, negative 8. And I get 0. Put R for remainder. The result of this division is a new polynomial. Let's see what it is. So if this is my remainder, this is my constant, 1, 2. So that's x squared minus 3x plus 4 is the result. And then in terms of rewriting, I still have my original factor, x plus 2. So if I multiply this together, I would if I multiply this all together, I would end up back at my original cubic polynomial. Always check to see, can we factor this any further? Well, let's see. A is 1. Are there factors of a positive 4 that add to a negative 3? Because 1 and 4 is tempting, but because this is positive, 1 and 4 won't help. So that means in terms of factoring this as much as possible, this is done. If we were being asked to solve, we would then continue to use quadratic formula if we were not able to factor. So we've checked to make sure this is not factorable anymore, and we're done with number 1. Number 2. Starting with these examples, so I'm actually going to back up before I write number 2. So examples, factor, and find all zeros. F of x equals 2x cubed plus 11x squared plus 18x plus 9 given that f of negative 3 equals 0. So let's talk about what this means. If f of negative 3 equals 0, this means x plus 3 is a factor, and the value x equals negative 3 is a 0. Also, note, each time we synthetically divide, the degree will decrease by 1. So we're starting off with a cubic. When we run synthetic using negative 3 in a moment, what will the result be? Well, 1 less than 3 is 2. So the resulting polynomial will be a quadratic. Let's see how this will work. So using negative 3 outside the box, let's check for placeholders. 3, 2, 1, 0. No placeholders needed. 2, 11, 18, 9. Go ahead and press pause and run this through synthetic, and we'll see if we match. So I drop the 2, multiply, negative 3 times 2 is negative 6. 11 minus 6 is 5. Negative 3 times 5, negative 15. Adding straight down, I get 3. Negative 3 times 3 is negative 9. Add straight down, we get 0. So I expected to get 0 as a remainder because I was told f of negative 3 equals 0. So that's good that that worked out. Let's get our small little labels. This is my constant. 1, 2. Press pause. How are you going to write this quadratic? The resulting quadratic is 2x squared plus 5x plus 3. Put that in parentheses. And we don't want to lose track of what the original factor was. My original factor was x plus 3. Just a quick reminder, if x plus 3 is the factor, if x equals negative 3 is the 0, x plus 3 is the factor that comes from it, right? If I set x plus 3 equal to 0, I would get negative 3 as a result. Let's see if we can keep factoring. Remember, when a is not 1, the rules change a little bit. Remember, we need to guess and check. So I'm going to set up my parentheses, 2x and x. I'll leave x plus 3 there just so I don't lose track of it. So when a is not 1, we need to guess and check outer, inner equals middle. Bring back that prior knowledge. So I need to multiply the outer and the inner, and I'm looking to get 5x. Well, factors of 3 are nice to work with. So maybe I try putting 3 here and 1 here. 2x times 1 is 2x. 3 times x is 3x. So that actually worked out on my first try. Remember that c is positive, so both of these have to be positive or both of these have to be negative. And I have finished factoring. So if I set these equal to 0, I'm going to have 2x plus 3 equals 0, x plus 1 equals 0, and x plus 3 equals 0. We get x equals negative 1, x equals negative 3, and I definitely encourage you to use mental math on this one, but just make sure we keep track of our signs. So if I subtract 3, that will get me 2x equals negative 3. Dividing that by 2, we'll get negative 3 halves. And that's it. If this was not factorable, we need to use quadratic formula. And I only write that note just to make sure we don't forget we have that awesome tool in our toolbox. So this was awesome because we could factor, which made our life easy, but sometimes that might not be possible. And it's not that the quadratic formula is hard, so I don't mean to say easy versus hard. We would just have a little more work to show to finish finding the zeros if this hadn't been factorable. Moving on to number 3. Number 3 says f of x equals x cubed minus 2x squared minus 9x plus 18, given x minus 2 is a factor. So if x minus 2 is a factor, means x equals positive 2 is a 0. So positive 2 is going to go outside my box. Once again, I know I can use synthetic because this is a linear factor where a is 1. Let's check for placeholders. 3, 2, 1, 0. No placeholders needed. Go ahead and fill in your box and do the synthetic by yourself. So press pause, run through synthetic, and then write the resulting quadratic. Remember, when we're done at this step, the degree will be 1 less. So if I'm starting with a cubic, the results will be a quadratic. So press pause, do this step, and get your quadratic. And if you're feeling really awesome, keep going and see if you can factor. Let's see if we match. So writing down the coefficients. 1, negative 2, negative 9, 18. I drop the 1. 2 times 1 is 2. Add straight down, 0. 2 times 0 is 0. Add straight down, negative 9. 2 times negative 9, negative 18, add straight down, 0. So here's my remainder. Going backwards, we have constant, 1, 2. I get x squared minus 9. And I don't want to lose track of my original factor, so I will write x minus 2 right here. Can we keep going? I'm hoping as soon as we see x squared minus 9, we're like, yes, we can. Notice, I technically could have written x squared plus 0x minus 9, but this doesn't not really need it, so I just kind of skipped right over to x squared minus 9. Setting this equal to 0, I recognize x squared minus 9 as the difference of squares that I can factor as x plus 3, x minus 3. Make sure we don't leave out the x minus 2. Setting each of these factors equal to 0, we get x equals negative 3, x equals positive 3, and x equals a positive 2. Number 4, g of x equals 3x to the 4th plus 16x cubed plus 64x minus 48, given x equals negative 6 is a 0. Please press pause and perform synthetic on your own. Remember to check for placeholders. Go for it. So I'm assuming we all definitely pressed pause so that we can check our answers now. Negative 6 goes outside the box. I check for placeholders. 4, 3, oop, 2's missing. 1, 0. So I have 3, 16, 0, 64, negative 48. Having a mental picture of where we're headed, we're starting with a quartic. We're starting with a 4th degree. So the result when we're done right here will be a cubic, a 3rd degree polynomial. Drop the 3, multiply, add, multiply, add, multiply, add straight down, multiply, add. We've got 0 as a remainder, which we expect it to happen because I'm told this is a 0. Working backwards, constant, 1. When I say work backwards, I think it's just easier to start labeling here. Constant, 1, 2, 3. So this means our result is 3x cubed. And if you didn't write this result yet, I'm going to pause right there. You finish writing the result, and we'll see if we match. 3x cubed minus 2x squared plus 12x minus 8. And right now this is multiplied by x minus 6. Plus 6. Excuse me. X plus 6. If the 0 is negative 6, the factor has an opposite sign. Always remember to write this because it's very easy to drop it by accident and then forget to put it in our final answer. So we're definitely not done because now we have this awesome cubic function right here. And we need to decide, sorry about that, we need to decide if we can actually go farther. Whenever I have 4 terms, my go-to tool in the toolbox to try first will be factor by grouping. What can I factor out of this first group as it's written? Well, 3 and 2, no common factor. But I see x cubed and x squared. So I'm going to get some brackets going here. I can factor out x squared from this first group, leaving behind 3x minus 2. On your own, decide what you can factor out of this second group, and if you can keep going, leave the video, pressed pause, and see how far you can take it. So when I look at 12x minus 8, I know they're definitely divisible by 2. So let's say I just tried 2 first. Don't write this, just watch. If I factor out a 2, I'm left with 6x minus 4. That didn't help, because this is 3x minus 2, this is 6x minus 4. But check it out. These are both still even, which means a larger even number was possible to factor out. So when I look at 12 and 8, I'm like, oh yeah, I can factor out a 4. So putting plus 4 here, let's see what's left. What do you multiply 4 by to get 12? The answer is 3x. And what do you multiply 8 by to get to 4? That's a minus 2. Remembering to leave x plus 6 here. I can now successfully factor by grouping. So when I factor out a 3x minus 2, that leaves behind x squared plus 4 times 3x minus 2 times x plus 6. If this had been a minus sign, I could keep factoring, but we do not have the difference of squares there. These factors are linear, there's nothing else I can do, so I will now set these equal to 0. We're going to set x squared plus 4 equal to 0, 3x plus 2 equal to 0, and x plus 6 equal to 0. Solving this one, square root both sides, we get x equals plus or minus 2i. Here, using mental math, if I subtract 2 from both sides, that's 3x equals negative 2. Divide by 3, we get negative 2/3. And here results in x equals negative 6, which we knew from the beginning. The original polynomial was degree 4. So how many zeros should we have? We should have 4. 1, 2, 3, 4. You know we're done. Very good. That was number 4. Here's number 5. Number 5 says f of x equals 3x cubed plus 6x squared minus 23x plus 4 given x plus 4 is a 0, is a factor. So x plus 4 is a factor, means x equals negative 4 is a 0. On your own, please run this through synthetic division and see what the resulting quadratic is. Make your decision whether or not it's factorable. If it's not factorable, remember that we need to use quadratic formula. So starting with this number 5, I'm going to encourage you to, whenever possible, press pause and see how far you can take it. Continuing on with you, 3, 2, 1, 0, no placeholders needed, so 3, 6, negative 23, and 4. Drop the 3, negative 4 times 3, negative 12, add straight down, multiply, add, multiply, Here's my remainder. Constant, 1, 2. So we have 3x squared minus 6x plus 1. And I don't want to forget my x plus 4. Setting this equal to 0, let's see, is this factorable? Well, my only options would be 3x and x. And 1 just has 1 and 1. So if I multiply the outer, that gets me 3x. Inner gets me 1x. There's no way I'm getting to negative 6 from there. So we need to use quadratic formula. Woo-woo! Quadratic formula. So please press pause and run this quadratic through the quadratic formula. I'm also going to press pause. When you're done and you press play, all of the quadratic formula work for this quadratic will be on the screen. So please make sure you press pause right now, and I will too. Hello again, I am back. And if you have pressed play, I'm assuming you have finished your work on the quadratic formula as well. I got 3 plus or minus 2 root 3 divided by 3. So if we don't match, take a second please to press pause and see where we differ. And if you have any questions on that, please let me know in class. I'm all set with taking care of this quadratic. And I just need to remember that I still have this little guy over here. So from that one I get x equals negative 4. I have 1, 2, 3 answers, and I should because my original was a cubic. Remember that this is a plus minus, so this is not repeated, but there are 2 answers here. So 1, 2, 3. Number 6. This is our second to last example. F of x equals 12x cubed plus 8x squared minus 13x plus 3. Now, the given 0 is x equals 1/2. Yay for fractions. This is going to be fun. So, I will get this going with you. The fraction goes outside the box, so I've got 1/2 outside my box. Let's check for placeholders. 3, 2, 1, 0. No placeholders needed. So I've got 12, 8, negative 13, and 3. Everything is the same. We drop that first value, so drop the 12. Let's multiply. Half of 12 is 6. Add straight down. We get 14. Half of 14 is 7. Add straight down. Negative 6. Half of negative 6, negative 3. Add straight down, and we get 0. I'm told x equals 1/2 is a 0, so I did expect to get 0 as a remainder. So 0, constant, 1, 2. This results in 12x squared plus 14x minus 6. And then how do I write this? How do I take this and write a factor? Well, for right now, we'll just write it as x minus 1/2. So just like if this had been x equals 5, you would write x minus 5. Same idea. Let's see. 12x squared plus 14x minus 6. Before I do anything else, if I see 12, 14, and 6, I know that I can factor out a 2 from that. So factoring out a 2 results in 6x squared plus 7x minus 3. We are going to take this 2 and send it in to that factor. So this second factor becomes 2x minus 1. So we factored out the GCF from this quadratic, which was a 2, and then we multiplied that 2 through this second factor, resulting in 2x minus 1, which is a much nicer factor to be working with. Let's see if we can factor this by guess and check. So I'm going to try 6x and x first. If I put a 3 here, I know 3 times 6 is 18. So that would be a 3 here and a 1 here. That's too big. So maybe I try 3 here and 1 here. Well, outer would get me 6x, inner 3x. That's still not going to help me out very much. So instead, maybe I try 2x and 3x. Let's start off by maybe 3 here and 1 here. So 3 times 2, 6. 1 times 3, that's not helpful. Nope. Maybe I try 3 and 1. 3 times 3 is 9. Ooh, this looks like it could work for us. So the outer gets me 2x. The inner, 3 times 3 is 9x. C is negative, so that means I get to get one of these as negative. If I'm trying to add to a positive 7, that means the 2x needs to be negative to add to that positive 7x. What got us the 2? Was it the outer or the inner? 2x times 1, so it was this outer. So that'll be negative, this will be positive. Let's just clean it up a little bit before we keep going. So it's 2x plus 3, 3x minus 1, and then 2x minus 1 is my factored form. Setting each of these equal to 0, here we get x equals, let's try using mental math on all of these. So subtract 3 divided by 2 results in negative 3 halves. Add 1 divided by 3, 1/3. Add 1 divided by 2, 1/2. Last example for today, number 7. A rectangle has an area of x cubed minus 2x squared plus 3x minus 18 square meters, and a width of x minus 3 meters. Find its length in terms of x. So if I know I'm dealing with a rectangle with a length and width, we know area is length times width. So if I know the width, and I know area is length times width, how can I work backwards to go find the length? Divide area by given width to find the length. And we've got all the tools we need to do that. I know that this is a linear divisor where a is 1, so we can use synthetic. What's going to go outside the box? Well, the 0 that would come from that is a positive 3. Let's check for placeholders. 3, 2, 1, 0. No placeholders needed. 1, negative 2, 3, negative 18. dropping the 1. Let's get to it. Multiply. 3 times 1 is 3. Add straight down. Multiply. Add straight down. Multiply. Add straight down. Here's my remainder. Let's go backwards with our labels. Constant, 1, 2. What is the resulting quadratic? You've got x squared plus x plus 6. In my other and I'm not going to set this equal to 0. So the width is x minus 3, so I was kind of just going to have fun with this and write done. But the reason we're saying we're done is that we were just asked to find the length in terms of x. So area equals, this was the width that I did know, and you just found the length. So the length is x squared plus x plus 6. And as soon as a value is assigned to x in this real world scenario, you would actually be able to use this to find the numerical value of the length. Nice job today on our first day of 4.4 polynomial zeros. You do have a homework worksheet, which is day 1 and 2. So see what you can try for the first part of that homework. And any questions, please feel free to send me a message on Remind. Have a great day, guys.